we go. Equilibrium problem number 3. Ah, ah, ah. We have here a rope that is 10 meters long, and there is a weight suspended in the middle of that rope. The weight that's being suspended is 64 newtons. Notice it's in newtons, so that's already a weight and not a mass. So if we were to draw a free body diagram, we would have to pick a point where all the forces are acting, and that point is where the sign is hanging and the two ropes meet. So here's our point, and we have two ropes, and two ropes, ropes can only supply tension, which is a pull. So we have two forces, one in this direction and one in this direction. And each one make an angle of 55 degrees vertical. Now, this is a little tricky to diagram on the free body diagram. Oops, I guess I forgot the 64 newtons is acting straight down. What I was saying was we need to split up T1 and T2 into their x, y components. So we technically have two x components here, or sorry, two y components, and two x components. And since those angles are the same, that means that T2x and T1x will have to be the same, equal and opposite. But the only two forces acting in the x direction, so they have to be equal and opposite, so that this thing is in equilibrium. We also know that we have two forces in the y direction. We have T1y and T2y. And so it's a little bit tricky to see because it kind of starts to get jumbled up in there. But if those angles are the same, that means that those two y components are the same. That means that T1y plus T2y has to be equal to the opposite of the force of gravity, which is 64 newtons. So basically, those two together have to be equal to 64 newtons. That means that each one of them is 32 newtons. Well, with that, you know now a side, and you know the angle through which that force is acting. You can calculate T1 right now. T1, let's say that T1y is adjacent to the 55 degrees. So cosine of 55 has to be equal to the adjacent T1y over T1, the hypotenuse, which is 32 over T1. Again, these two can switch places, so T1 has to be equal to 32 divided by the cosine of 55. Calculate that out. What do we get? T1. Let me push the buttons on my calculator here. 32 divided by cosine of 55. I calculated 55.8. Oh, so that's not degrees. That's newtons. We already know the angle. Boom. That's all there is to equilibrium problem number 3. T2 has to be exactly the same, because this is symmetrical. We could prove that mathematically if you wanted to go through. If we calculated T1x, you would have to say that T2x is equal and opposite to T1x, and doing the math, you could calculate that T2 is equal to T1.